They are, what we're looking at is angle measures. All right, now I know you might look at this and think we don't know how to do this, but let's fill in what we know and let's see if some other things help us, okay? So you saw me draw this with a straight edge, okay? So maybe you've heard this before, maybe it sounds really strange, but I'm going to say it this way. All lines are straight. So you don't have to say straight line, okay? Anything that connects 2 points is not necessarily a line. Hang on. Unless it is straight. Okay? Yeah, it would be a segment. But a segment also implies that it's straight. But if it's not straight, we don't call it a line. Does anybody know what we call it?
A wiggly line.
A curve. We call it a curve. All right. But these are lines. So let me give you some information. Line CO intersects line AB at point, where do they intersect? What's it called? What's its name? X. Okay, so let's make sure we understand what is being said here by this picture. Picture's worth 1,000 words, probably more in math. So, line CO, let's break out the colors. Yeah, okay.
Does OXB equal 60?
No. It's really close though.
Okay.
And then AB, here's line AB. And what does intersect mean? It means they cross. How many places can two lines cross? Only one, because by definition, if they are lines, they are straight. The only exception to that would be if one line was placed on top of another line, they would not intersect at one point, but all points. Okay? So, stop and think about what I just said. I saw some eyebrows go. So, two lines can only intersect at one point unless they are the same line. They're one on top of the other. Okay? But all we have here... Yeah, sort of. Okay, so line CO, and then we have line AB, and then the point, and it's very important that you understand that's a point where they intersect, is X. How many angles have I created?
4, 5.
Basically 4. Now I'm going to ask you a weird one like AXB, but we'll get to that in a second. So when two lines intersect, you have 4 angles that result. Okay? I told you that AXO is 110 degrees. And Adeline has already begun thinking, well, I think the next one's 60. She's really close. So if this is 110 degrees, I want you to think about something. Okay?
BXC equals 110.
Okay, whoa. What?
BXC equals 110 because it's the same length from the other one.
All right. So
or it's the same angle.
It's the same angle. There's a vocabulary word I'm going to introduce here. So let's make sure you hear what she said. BXC is also going to be 110 degrees. You see this amount here, this opening is equal to this opening because these lines are straight. So BXC is going to be 110 degrees also. Okay? Those are going to be equal. Now, that's always going to be the case because when you have two lines intersect, let's do this too. This is called vertical angles, okay? Vertical angles. And I'm going to draw a tiny little picture here too, okay? Yes, Liam? Hang on, okay? Can you hold on just like 30 seconds for me?
I have the answer for AA.
All right. Both of you hold that thought just for a minute. I'm going to try to go as quick as I can. Let's see. W, X, Y, Z. Now I want you to think about something. I'm trying to give you the definition of vertical angles. And it's whenever one angle is opposite the other in a picture with two lines that intersect. So, the angle W is equal to angle Y. Angle X is equal to angle Z. Vertical angles are always congruent. That's the mathematical word for equal or the same. Okay, so have this little picture somewhere else on the page. That is the rule or the reason why AXO is going to be equal to BXC. Okay? AXO is equal to BXC. Now, Liam, you were going to tell me the answer to what? OXB.
I said it, OXB.
OXB. What do you think it is?
70.
70. Okay, why? Hang on, Evelyn. How did you get 70?
You subtract a 110 from 180 degrees and get the amount of degrees.
All right, so let's follow what Liam's saying. AXB is what is that?
It's straight, it's 180.
A straight line equal to 180 degrees. So AXB is 180 degrees. Excellent. Now, if you know this total is 180, then we're just going to subtract the part that we have from the 180 to find the missing amount, right? So that must mean, we're going to say that's 180 minus 110, that's 70 degrees. So OXB is 70 degrees. Once we know that, Adeline, did you say you knew what AXC was? This one.
Yes.
What is it?
Wait,
AXC.
that one's 70.
That one is also 70. Now, I'm going to ask for a reason. Do you know the reason?
It's the same angle as the other one.
It's vertical to OXB. Okay? So CXA, AXC. What we have here, we have two different things. Okay, we have vertical angles, which this is the picture. W and Y are the same. X and Z are the same. That's why I use the colors. And then we have this concept of two lines that work together, two angles that work together to form a line. All right, so let's write that definition. Okay, here's number one, vertical angles. Number two is going to be linear pair, or, bless you, supplementary angles, okay? Okay, a linear pair, also known as supplementary angles. Here's my line. Notice I didn't say straight line, because by saying line, I'm implying straight. Here, you can even tell. I'm going to use a straight edge. Okay? Linear pair. Linear pair. Linear pair. What's the root word in linear?
Linear.
Line. It's a line. So, if you learned anything from this picture up here where AXB was a line, it had an angle measure of what? What's the angle value for a line? What is it?
180.
Right. So we're going to measure 180 degrees. But linear pair implies two parts. Two parts. Okay? So, let's just separate it somewhere. Okay? Let's call this angle, let's call this K, let's call this L. What do we know if these two angles form a line? They are considered a linear pair, which means their sum is what? They form a line, and a line has a measure of 180. So, Allie, 180, yeah. 180 degrees. So, a linear pair means the two angles are supplementary. Again, supplementary means their sum is 180. So, I'm going to abbreviate here. That means the sum equals 180 degrees. Okay, so you're going to come across this in Delta Math. I want to make sure you have the right definitions. You can go back and look at your notes. Do you guys ever use your notes when you're doing Delta Math?
No. Sometimes. No. Nope.
All right, the teacher asked the question to try and change your behavior. We'll see. Okay, but this is always, not sometimes, not never, always going to be true when this is a line, the two angles that help form it are supplementary. They're called a linear pair. Questions so far? No? So let me just go back and review, make sure I get the definitions I wanted to get. Vertical, adjacent and complementary. All right, so adjacent is not a word that people use anymore, is it?
Never heard of it.
Never heard of it. All it means is beside, okay? So, let's draw one more diagram. Let's call it diagram 2. Still part of lesson 69. And yes, we're going to go back and do 68. But diagram 2. I'll take my straight edge. It doesn't have to be perfect. Just try to get close, okay? Okay. Yeah. Let's call this A, B, C. We'll put a point up here to make sure you guys see that these are segments. And then D over here. And then we're going to put X in the middle. And I put X because it's kind of just indicative of an intersection. Now, yeah, okay. You too? Oh.
Get a piece of paper.
Yeah, sure.
No.
So, we're drawing that, but I put another symbol on this one, didn't I? You guys know what that symbol means?
Right angle.
Yeah, it means right angle. It's not wrong. No, it has a numerical value too, right? What is it, Macy? 90 degrees. All right, so when you see this symbol, you should recognize it's 90 degrees. Okay? But adjacent simply means beside. Okay? I'm going to put that in quotations. Adjacent means beside. So we could say that angle AXB is adjacent. Adjacent. I didn't spell it right. Oops. Bless you. Is adjacent to what's beside angle AXB? Angle BXC. Okay? Don't freak out when you see that word. Add it to your vocabulary. That's actually not the one that you're going to be asked more about here, though. So, supplementary on the previous page meant two angles that do what? They add up to get 180 degrees. Well, let's see if we can find something that's going on with angle BXC and angle CXD. Firstly, we can see that they're right beside each other, so we could say they're adjacent to each other. But secondly, I'm more concerned with their numerical value. So let's suppose that I tell you, you have to be given something like this, the measure of angle CXD, what do y'all want it to equal? Let's make it 50 degrees. Okay? 50 degrees, okay? I didn't do any work, that's just part of the problem. Let's say that the book told you that. What you should be able to do now is tell me what is the measure of angle BXC? What is the measure of angle BXC if you know this is 50 and this just happens to be on the other side of a right angle?
70.
70? How'd you get that?
I'm
Just
just guessing.
guessing.
Oh, BXC.
Any guesses other than Grayson's?
40.
Allie? 40? All right. Why do you think 40? All right. Because 50 and 40 add up to 90, why does this part have to be 90? It's the other side of the linear pair, which has to add up to 180. Okay, so we happen to know that based on the previous page, right, what we're doing, we're building our logic here. Well, this has to be true because we figured this out. Well, now this has to be true because this. Okay? That's what logic is. And there's a lot of it here. So if we know that this is 50, and we know the entire thing has to add up to 90 since it's supplementary, then we can say 90 minus 50 equals 40 degrees. So this one has to be 40 degrees because of that. Those angles are called complementary. And I misspelled this for years. It actually doesn't have an I. I guess that's a different word. Complementary. The sum of angles equals 90 degrees. Okay? So, said another way, we could state that angle BXC is the complement to angle CXD. Okay? Yes, I said complement. That's just the noun expressing that they have a relationship where their sum is 90 degrees. Okay? So, supplementary, they add up to 180. Complementary, they add up to 90. Supplementary, they add up to 180. Complementary, they add up to 90. Let's just check out you think it's what? 90. Why do you think it's 90? All right, let's talk about something, folks. Shh. That's the one we know. What is the relationship of 119 and H? What is that called? Liam? I need to know what it's called, and then you can tell me the answer. Do you know? What is it, Luke? Well, H is an acute angle, but I'm looking for something from the last page, guys. They are adjacent, but they are supplementary because we're calling it a linear pair. Okay? So if they are a linear pair, Corey, would you get the door for me, please? If they are a linear pair, then they do what? Macy? They're going to equal 180 when you do what with them? When you add them. So we know that H and 119 have to add up to 180 degrees. So H has got to be 61. Okay. Adeline, can you tell me what G is? $119. Can anybody tell me the reason? Macy? What's that called? They're congruent, but why? What's the relationship between the angles? We call those... Sorry.
Vertical.
Vertical, yeah. Vertical angles are always congruent. That's the word Sophia used. That's what we're going to continue to use. Equal. Okay? So G is 119. H is the linear pair to 119, otherwise known as the supplement. Okay. Huh? Well, there's right there. So yes, we can. Okay, if you haven't done, what you got?
Is that 121?
Yes, it's 121.
It's 59.
So M equals 59. It is called the supplement. K is equal to 121. It's the linear, or it's the vertical twin. It's like a twin, right? Yes, Carter.
But it's going to cost you like 4 minutes.
All right. So, go now. So that's what we're going to be looking at for lesson 69. Now it's time to go backwards and go to 68. Okay?
I have a question.
Yes, Grayson.
How much more minutes do we have? 15, 10. 10 minutes. Let's go. Come on in now. 12 minutes.
All right. So lesson 68. It'll go by fast. Because I had a lot more to draw in 69. 68 is going to be a piece of cake. We're going to divide mixed
Numbers.
or in reality that's a trick. We're not going to do this. So let's take a look at example 1. Let's do 4 3/5 divided by 2 3/10. Okay?
I don't like that.
All right. Here's the thing. the topic is dividing mixed numbers, we're actually not going to do it. You see these are both mixed numbers, but we don't have common denominators. We might not need them. But you actually, you can't touch this. Da-na-na-na. Until, sorry, I need a better way to do that. Until you convert them to an operable form. Okay? Here's the reason. This means, don't write this part, this means 4 plus 3/5 divided by 2 plus 3/10. When you see it that way, you're going to realize, I don't like that. That looks weird. There's a lot going on there. So, instead of doing that, we're actually going to convert to improper fractions before we try to divide, okay?
Do we write that?
Yeah. Yes, you do. Right, first. That's what you do first. So how do we convert to an improper fraction? We multiply and add. 4 times 5 plus 3. So 23 over 5. Is that what you said, Sophia?
Yes.
So divided by 2 times 10 plus 3. 23 over 10. Now it looks more like a previous lesson from like 2 or 3 weeks ago. But we still don't divide fractions. Hope you like fried chicken. Actually, that's not it, is it?
I love fried chicken.
All right, we're going to keep the first. Shh. We're going to keep the first. Okay? Keep the first. Fifth. We're going to flip the second. So that becomes 10 over 23.
Keep changing.
And then change the sign. We're going to change it to multiplying. So we're not going to work it this way when we stack it, but I was just trying to keep track of the steps because I put KFC. Keep the first, flip the second, change the sign to multiply.
That's not how I do it.
All right, so 23 over 5 times 10 over 23. Watch what I can do. They both become one giant fraction, right? What can you do when you have the same number on top and bottom and they're multiplying?
Cross them out.
Cross them out, cancel. They reduce to 1. What's 10 divided by 5?
Oh.
Oh, that was a nice and sweet answer.
What the heck? How'd you get 1 half? How'd you get 2?
10 divided by 5.
Oh, you're dividing them, not trying. Yeah, I thought you were going to.
Well, look, I did multiply them here. That's why I wrote it this way. Kind of like the prime factorization lesson from last week. Okay, where you can cancel, you can slash them out when they have the same number on top and bottom, and they're multiplying, not adding or subtracting.
Kentucky
Wait, can we do one more number? I mean, one more?
Oh, absolutely. We're going to do one more. All right. 3 1/3 divided by 2 1/4. Okay.
Let's do 1 and
10/3 times 4.
40 over
97. Oh, I did the other thing.
97? 27.
I did the other thing.
Oh. That's my God.
1 is 13, 27.
Now, unless it tells you give your answer in this way, you can do either one. You can leave it as an improper fraction, or you can convert it to a mixed number. If it's a mixed number problem, it's kind of nice and expected for you to put your answer as a mixed number. But both of those would be correct.
So so you had 10 over 3 and 9 over 4 equals, and then what do you do after that?
You keep the first, change the sign, and flip the second.
I did it.
So we don't divide fractions. We actually multiply. We change it to multiplication every time.
Anytime. Okay, that's it.
Yeah. Good. All right. So, see if there's anything else that's difficult in this. I don't think there is. 68 is pretty straightforward.